The cool thing about MATLAB is that you can always just use the MATLAB manual to get whatever information, do whatever you want, just using the manual itself, nothing more. But for now, I have a summarized version of the manual, MATLAB manual for you, about the most important methods of inputting and outputting data in MATLAB. So if you recall, how many methods of inputting data we have tried so far? Do you remember? Can you name them? What methods we have tested so far? Yes. Yes, but basically, what do those mean? It means you either get the information from the command line, you get it from the, or you can get it from the bash command line, like the like things that we did like in the beginning of the semester. You remember we ran a MATLAB code from a bash command line. You would say MATLAB dash run the name of the script that you want to run. No splash, right? So those flags. So that's another method. So you can run it from the command line, from the Windows or Linux command line or Mac command line. You can run your code on MATLAB command line. So get information from the MATLAB command line. You, like for example, input. You say input and then you get the information. How about other methods? So you can also develop graphical unit interfaces in MATLAB. In concisely, they call it GUI. So basically what it means is that you can create a window just like MATLAB itself. MATLAB is basically GUI software. What does it mean? It means that it has different places that gives you the ability to interact with the software. You can click by mouse on this section and then modify things here, modify things here, anywhere else. So you can also do the same thing and build another software that looks like MATLAB in MATLAB itself. But I've rarely tried it myself, except like when I was really young and adventurous. And you probably won't need it for yourself if you stay in academic environment and for your use MATLAB for academic research. But there is another one which is really important, and all of you need to learn, and that's probably what you're going to use for 99% of your programming life, and that's through what? Can somebody tell me? What is the last method of input-output? Reading and writing a file, yes, and plotting. That's also true. So that's basically plotting is basically writing to a file a set of code, a set of information that is not in ASCII format. So it's in binary, and it can be interpreted as a JPEG image or PNG image, right? And we're going to learn them all briefly today. So this is the first method that I told you, like you input the variables on the command line. But one thing you have to keep in mind, never hard code information in your programs, in your MATLAB scripts and any other language. What does hard coding mean? Does anybody have any ideas?
Actually putting the data in your program.
Yes. So basically what it means is that, for example, you want to define, let's say you have a code and you want to generate in your code 10,000 random numbers, okay? So I could say rand 10,001. That will create, do you see it well? Is that big enough? I mean the font size here. If not, just, maybe it's not, so let me enlarge the font again. This is a big dilemma for me because after the class I have to shrink the font size to 12 so that I can read it myself, and then in class I have to enlarge it again for you. So let's say you want to create a sample of 10,000 random numbers and then you want to plot them. So I put this in, this is a uniform distribution, so I call it unirand. Okay, you can try it yourself and then see what you get. So this would be simply a plot unif. So this is a histogram plot. We will learn about plotting soon, either today or some other time. So what this does is that you say, create a variable, renif_rand, that contains 10,000 random variables that range between 0 and 1. That's what rand does for you. So it creates random numbers between 0 and 1. And now I say plot a histogram of the variables, the values that you have. What, do you all know what histogram plotting means? Do you have any ideas what histogram is? So, yes? Sort of, yes. So what histogram plot tells you is that it says how many numbers in that 10,000 numbers that you generated fall between 0 and 0.1. How many of them fall between 0.1 and 0.2? How many fall between 0.1 and 0.3? So you could change the bin size to whatever size you want, but using MATLAB. So I could say, the good thing with MATLAB is that everything is an object. So I can define, again, we'll get to this plotting stuff soon, but to just give you a quick introduction, you can define plots as objects in MATLAB. So what does that mean? I can say histogram, H equals histogram of this data. Now if I do this, I regenerate the plot, but then the cool thing about it is that I can type H dot, and it's a structure. So this MATLAB plot becomes a structure that contains all of the information about the plot that we had. So for example, what was the plot? So we had this plot. We want to know what is the range, the limit for x-axis. Let's see if we can find it here. Bin limits. So let's see. Bin width. So if I type bin width here, what do you think it's going to give me? 4? 0.05. Great. Awesome. Yes. Because the width of each bin here is 0.05 almost. So let's see if that's correct or not. Yes. Perfect. Okay. So then through this access to all the attributes of your plot, your histogram, you can modify the histogram to whatever you want, to whatever format you want. Okay. And you're going to learn about this soon, and you will, well, you don't have a homework about it necessarily, but histogram is really easy. I can teach it in a matter of minutes. But the point was that, so now we want to compare this plot to a distribution of normal random numbers, normally distributed. So I could say norm RND, or norm RND, both norm RND and rand n generate random numbers for you. But there's a difference between them. Rand n generates standard normally distributed random variables. What does it mean? It means that the mean of the distribution will be at 0. The average value for all the points that you generate, all the random numbers, is at 0. And the width of it is about 1. Okay, let's try this and then see what we get. Hopefully what I'm writing here is correct. And this is not unif RND, it's norm random number. Okay, now I want to plot norm histogram. So I call it n, or we call it n hist, and u hist. Okay, but then there is a problem with this code. I don't expect you to know, but does everybody know what's going to happen? We don't get what we want. We don't get 2 histograms. And it's because, let's try it and see what we get. What happened? There's a problem somewhere. No? Oh, so I closed MATLAB. That's a problem of having too many windows open. Let me close a few things, clean up a little bit. Okay, good. And we don't need this one. Okay, now we're back. So let's try it again. Press F5, it runs plot unif, and then let's see what we get. we get only one graph. What do you think happened? Well, the problem is that, first of all, both plots are plotting the same thing. So this should be norm rand. But then again, we don't get the desired behavior. We do, but the other one is lost. You see, so we only get one of the distribution. This is a distribution of normally distributed random numbers. Okay, with mean 0 and standard deviation of 1. Okay, so this is exactly what this norm rand contains, and this is a histogram of norm rand. But what happened to histogram of unif rand? Because if I press F5, you can try it yourself and type this code in your own MATLAB. You won't get the other one as soon as you have another histogram right after the uniform histogram. So if I press this again, see, I close the window, figure, and then press this again, I get only one graph. The problem is that every time you define a plot, you want to plot something, you have to define a new figure. We call it new figure handle. Right, so I would say for the first one you don't need it because it's automatically created. So I could say figure here or just ignore it. But for the second one, if I want to have it in a separate plot, then I have to create a new figure handle. So I say figure, press F5. Now I get two figures, you see, the uniform distribution, the normal histogram. Okay, and the reason is that when I wanted to create the second histogram, I said create a new figure for me. You could also label them. You could say figure 1, figure 2, figure 3, so to whatever you want. Okay, so for the first one you don't need it, but for the second one you need it. What I could say, so what if you wanted to combine these two? I didn't want to teach you plots, but it's so interesting that I wanted to tell you a few things right now. Yes?
So basically, if we were like plotting line graphs,
yes,
we never declared another figure. We would just multiple lines.
Right, very good point. So what if you wanted to combine two figures with each other and see how they look like compared to each other? Let's say, for example, we wanted to combine, that's exactly the question that you had. Let's say we wanted to combine normal distribution, normal histogram with the uniform histogram. So how would we do it?
Combine.
No, there's no combine instruction there. So the solution is, it's not combined, but it's named something else. It says, no, hold, exactly, but not hold alone, hold on. Don't go anywhere, okay? You say hold on, and then you add the next plot to it. Let's try it this time. You see, the uniform distribution is now behind the histogram of normal distribution, random variable. You cannot see it well because it's one is on top of the other one. So the solution is, for these sorts of problem, how do you fix it? If you want to see the smaller distribution better. Yes, switch them. So you switch the order. So I would say put this norm R&D before uniform R&D. Now if I do this, let's close this one and then press F5. Now I get the uniform distribution on top of normal distribution. Okay, but so we basically covered a lot of the plotting in MATLAB lecture, but the point of this writing this script was that suppose you have to create all of these different distributions, and then all of a sudden I tell you I didn't want 10,000, I wanted you to plot 100 points or 500 points. Then if you have coded like this, you have to go back to your code and change all the numbers that are 10,000 in your code to something else. Okay, that means hard coding. This is called hard coding, which is really bad because suppose you had to have 10 histograms, all of which had the 10,000 number, then you would have to rewrite multiply 10,000 to something else 10 times. So the solution to this problem is to define a universal variable. I say n sample, the total number of sample points. And keep in mind, whenever you have an integer, most often, as a convention, again, this is a convention, but it's a good convention. Most often you would want to name it with the letter n, or what other variables are for integers? I, j, k, n, and m. These are the most used variable names, letters for integer variables. Okay, so if you use this convention, whoever else, probably almost the entire programming community uses this convention. That it's a variable that starts with n, or especially with n, or I and j or k, then that probably contains an integer. Okay. So that's a good convention because it immediately tells the user what the variable is. So I say n sample. Why do you think people use n, especially for number of things? Because it's the beginning of n, right? Number. So number of sample points. So n sample is 10,000. Now I can copy this, put it here, and also here. Now there's no problem. As soon as I want to change this to something else, I just change the n sample to something else, and I'm done. So I get a sample of 500 points now. I want to change it to 10 points, change it to 10, run it again. Okay, so this is with 10 points. No, a problem happened. I've got 4 histograms on top of each other. Why did this happen? Because I told it to hold on forever, right? So the solution is, once we are done with the plot, we don't want to add anything else. What should we say? Hold off, yes. So as simple as that. You say hold off, and you're done. Okay, now if you run this again, this is a plot of 10 sample points. Okay, so very simple. If you want to plot things together, hold on, and then hold off. All right. Now, that was about the hard coding and how to avoid it. So you should always try to define variables as much as possible. And this is not only enough. Most often you would want to let these variables to be determined by the user without going to your code. So you would you better have something like this: input instruction here, and say input and sample, and you get it from the user. This is a much better approach. So it's say n sample equals. Okay. Now if I say plot unique, it says enter the number of sample points. I say 10,000 again, and it plots everything for me. It looks like this. Okay. Now let's go back to our original problem, plotting. Okay. So there is a lot of different ways I'm sorry, not plotting, reading, that you can read and write data in MATLAB. So you can do it in the most primitive ways, using fprintf, which is taken from C, language C, which is very primitive, and you have to do a lot of formatting. So you won't like it, just like me. But there are other ways of inputting and outputting data that are really important. We will learn them. So one of them is load and save. Okay. So now go to your MATLAB. Suppose, assuming that you have done something already in your MATLAB and you have some variables defined. So do you all have some variables defined here in your workspace? Okay, good. So now you could say save MATLAB variables. Okay. .mat. Mat stands for MATLAB. So we are going to save the entire. If you type this and then press enter, MATLAB is going to save the entire workspace for you, all the variables that you have defined here, in a file called MATLAB variables.mat. It's a binary file. You cannot click on it to see the content of it. The only way to see the content of it is to reload it again in MATLAB. So let's save it first. So I say save MATLAB variables. And now on my desktop, which is the working space for MATLAB, I have MATLAB variables. Okay. Now, suppose I clear all my workspace by mistake, by an intentional mistake. So everything is gone now. Okay. Now, how do I get it back? If I wanted to have all those variables back again, I would say load. And all the variables come back to my environment. From the last snapshot that I took from the MATLAB workspace. Okay. This is probably one of the most useful methods of inputting and outputting data in MATLAB. But that's only specific to MATLAB. You cannot use the outputted data in any other problem, any other software. That's what I mean. So you can only use .mat files in MATLAB, and probably another software. What is it? There's a free version of MATLAB, a reverse engineered version of MATLAB. What is it? Does anyone remember from the beginning of the semester? GNU Octave, yes. It's not GNU. GNU is the organization who bankrupts all these software companies. But the specific software that they built to compete with MATLAB is called Octave. GNU Octave, yes. So basically they have a freeware for almost any commercial software that is worth spending money on, which is good. I mean, they control the price of software for us by creating competition. So what do I want to tell you? Okay, let's go to the lecture notes. If you go to the project, we are going to solve the first part of the problem in the project. By the way, I haven't received the the group leaders and project repositories yet. So if I go here, grades, final projects, name triples, I have the names and everything here. Okay, so I have received 3 and one more who emailed me 3 a.m. last night, or 1 a.m. I'm not sure when exactly, but yeah, so that one is left still to be added. But if you send it to me, then I can add it here, and then I can keep track of your progress. The thing is that if you send it to me, please send it to all the TAs and me, not me only. So Travis, Sanjit, and Vivek. Okay. Now, if you go to the, let's see, if you go to the project, end of the semester project, we're gonna solve the first part of the problem. So it's the simplest part, unfortunately. So we have an input data that we want to analyze. So let me tell you a little bit about the entire structure of this project. So what do we want to do? I have given you a data set, and you want to extract the information from this data set and then analyze it. So basically your problem is this. That's the flow of information in all MATLAB problems. The first part, you input data from some file to your program. So this is the flow of program. And then you analyze data. For example, clean it up, make plots. And then you may also want to form a hypothesis and test that hypothesis given this information that you have been given, right? So for example, here in this case, we have a set of data about the growth of a tumor in a rat's brain. And now our hypothesis is that the growth of this tumor follows very well the convergent growth. So we'll see what the convergent growth is. But it's basically like an exponential growth. It's an exponential growth that levels off at the top. So it's something like this. So our hypothesis is that the tumor grows and then eventually becomes almost flat in the end, because it reaches the boundary of the skull and it just cannot grow anymore. So the growth of the tumor stops. So this is time. This is the number of tumor cells. Okay, so it will look like something like this. This is our hypothesis. Okay, and now we want to test this hypothesis against this data. So then the last step would be hypothesis formation and problem solving. How do we fit this model to data? And that's a little bit challenging. So I encourage you to assign this part of the problem, your group, to someone who is more, who has a more mathematical thinking brain. So you will not have any problem with this part. These parts are rather straightforward, but still it has a lot of details. So like, for example, if you want to make plots, it's still, you have to learn about subplots in MATLAB. But it's a little bit more straightforward than this part here. This one is also really easy, but it's just a little bit more thinking. So, and then at the end, you may want to plot the results again. Plot the hypothesis prediction. So plot the model versus data that we have, and see if the two match or not, at least visually. Okay, so that's what we are going to do in this project. But the first step, as I showed you here, so there are almost 5 steps here, right? The first step is to get the data. How do you get the data? The data set that I have given you here is in the form of a mat file. It's a binary file, so it can only be read by MATLAB. There are also ways to read in other languages, but very limited. So now download this cells.mat on your desktop, and now it's on my desktop now. So it's in MATLAB working directory. So I'm gonna load it now. So I say load cells.mat, and it's a string, so it has to be enclosed with. So I'm going to clear my workspace, clear all, now load cells. So you see, as soon as I press load cells, I get the variable cells here, which is a matrix. So if you look at the structure of it, it says 4D double. So it's a 4-dimensional double. Okay, and if you recall from the structure that I gave you here, it says cells is a matrix, is a 4-dimensional matrix that contains y-axis, x-axis information, z-axis, and time. Okay. Now we will discuss this further. I don't want to spend time today about this. I just wanted to show you how you can load this information in MATLAB. So that's the first step for your project, right? So let's say we just want to see what the information looks like in this problem. So if you look at this plots that I have for you, you see on the first day, day 10, in this data set, I have 16 slices at different z positions. So z1, z2, z3, and then each z slice has 2 axes. It has y and x. Okay. Now let's say I want to plot day 12. So I want to plot the second time point in the data set, day 12, at z equal to 11. See what the information in this subset is. So how do I do this? I say there's a function called images_c in MATLAB that plots images for you, plots matrices for you. Okay, so I could say images_c cells. I want all the y-axis because I want to plot this whole plot here, this one, this single plot one here that has z equal to 11. So I want all the y elements, all the x elements, but the z equal to 11 element. So I would say y equals all of it, x equals all of it, and then z equals 11. And what day is it? It's day 12. So it's the second time point. This is the first, and this is the second. So I would say plot the second time point for me, and this is it. I get the plot I want. So now compare this to what we have here. You see, it's exact same thing. It's just a smaller version of this plot here. Okay. Now, if I wanted to add color bar to this plot, I could simply say color bar. Yeah, we got the color bar now next to it. Okay. So, task for one of your group members would be to get all these plots for all time points and then put these together in groups of time. So put all 16 of them in a plot group and then save it to a file. Okay, and we are going to discuss more plots throughout the semester, and we are basically pretty much done with the lectures. So right now, so most of the remaining lectures will be spent on how to solve the project and how to solve the rest of the homework problems.
Can you go back so I can see what you're at?
Yes, you want to see this? Yes. So you have to make sure that load cells.mat, the cells.mat is in the working directory of MATLAB. If it's not, then it won't work.
You did it.
So where did you save it?
I don't know.
Yeah, it's probably saved somewhere else, somewhere other than. The column means go from the beginning to the end. I could equally say go from 1 to end. 1 to end. That will also mean the same thing. But when you have, this is again a syntax borrowed from Fortran. That would do exactly the same thing. So what do you think if I said n divided by 2, what would happen? You get just a subset of it. It goes from 20 to 30, right? 0 to 20 in the y-axis, 0 to 30 in the x-axis. Why does this happen? It's just because so let me plot another one figure. So create a new figure and then plot it in full, and then let's compare the two. So I removed the previous one. So see, this is the whole figure, goes from 1 to 40 and 1 to 60, but you can plot the slices of data, which is meaningless. Why would you want to do that? Yes.
With the color bar, how did you get the color bar structure from? Because I'm just getting the color bar.
All you need to do is just to type color bar. That's it. You get it next to it.
I don't know why.
Makes it. Maybe you have multiple images open. That's why. But then you could also assign this color bar to an object. So I say cbar object is this. And then as soon as you do this, you get all the properties of color bar that you can adjust. For example, you can say location would be west outside. So instead of appearing on this side, it will appear on this side. Okay. So you could also say set the limits from 0, not from 0 to 3000 to something else. So right now it goes from 0 to 3000 up to here, right? And also the font size. You could also add label to it. So these are things that we'll learn in later times. What was that?
How did you get that?
All you need to do is to assign color bar object to a variable. And then that variable becomes a structure. So it has all the fields that you can adjust. So I could say color bar font size. Oh no, the limit, for example. Let's set the limits. Limits. It actually also has label. So let's add label. Label. This is fun. Okay. Quite not really informative, but you cannot set the read-only it's a read-only property. So I think, I don't remember, I think you could probably do it this way. Set cbar label. I'm not sure, I don't remember exactly how you add this label to color bar, but we can learn it for sure. No, you cannot do this. So I don't remember how I did it myself in the past, but you can do it easily. And let me go back to the problem, to the first problem in homework, because next week is going to be a very limited time for us. So if I go to the homework is due almost 10 days from now, but it's a rather difficult homework. So I want you to follow me for the first problem today and solve this problem. So what does the first problem tell you? It says open this file, student CSV. So let's open this file in CSV in MATLAB. So another way of importing information in MATLAB is through CSV read and CSV write. So I could say CSV read. So what does CSV read do for you? It's very clear, right? It reads CSV files for you. CSV means comma separated. I don't know V, what V stands for, but what was that? Values, yes. So very good point, thanks. So CSV is just a comma separated table. You could also open it in Notepad++ or any other editor and see the content. So this is the header of the file, and these are the values separated by commas. Okay, so that's basically the content of this file. Now you can use MATLAB CSV read to read this file. So I say students and then press tab. It's going to auto-complete it for you. And then let's save the information in a variable. So I say data. What happened? Error using DLM. I think there's probably something wrong with the formatting of this file. So let's read it with another more powerful data read instruction in MATLAB. So there's another method of reading data, and it's called import data. And this is more powerful than the other ones that we have because it's capable of handling a wider variety of data types. So it can read CSV file, it can read table, it can read ASCII data, it can read, I think it can also read binary information like math files. It can also read Excel files. So it automatically discovers what type of file you have and then it reads it automatically for you in the proper structure. Yes?
CSV read doesn't take anything that's not numeric.
Oh, right. Yes, that's because of the header. Yes. So if we remove the header from the file, thanks for reminding me of it. So now this, oh no, that doesn't fix it because it's not numeric. Yes. So how did I read it myself? So let me see how I did it myself last time. So we have pick a student tribble. Oh, I read it as a table. Okay. So there is another method of, you see, there's just 1,000 ways of reading the same information in MATLAB. So there's another type of information reading called read table. So this read table function reads the information for you in the form of a MATLAB table data structure. Okay, so let's do it with a read table just as I've done here. So student data equals, again it didn't work, why? Oh, so the problem is I'm not in this folder. Okay, now it should work. Okay, so I have now a student data whose class is what? What type is this? What type is this variable? It says read table, right? So that's going to convert it to a table. So it says it's a table. So what does a table mean then? It means that you can access its content. Let's see if it's in the form of a structure. Yes. It has three columns, var1, var2, var3, and then properties. I don't know what properties is. So, yeah, it's just something irrelevant. It's the properties of the table. But what's important for us is var1, var2, and var3. var1 is the ID of the students. What happened? Okay, yes. And var2 is the name and last name, the first and last names of the students. And var3 is what? The emails. Okay. So now, our goal is to, so we have this file, and now our goal is to read this information in MATLAB, and then another thing, also to randomly assign the students in groups. So here is our problem. So how do we approach this problem? We want to assign random sets of triples of these people in different groups. So form groups of 3 people from this data set of 99 students. So how do we do this? So here's our problem. I have, and then this is, so I have a table. I want to construct a table whose rows correspond to each group. Okay, and then the columns are the members of the team. So each group has 3 members, right? Now these boxes are empty right now, and we want to fill them with the students randomly. The question is, how can we do this? Right. So we have 33 rows here and 3 columns. So the solution to this problem is to do this. Each student has an ID, you see, but these IDs have been sorted according to the names. So it starts with A and it goes down to Z, right? So this is not a good solution. If you just pick the first 3, all the group members are going to be the same last name, almost. They all start with A, right? So we cannot just pick 3 people from this list in a sorted way and then put them here. So the solution to create a randomized group of people is to pick randomly from this set and put them here. But then there is again a problem. If I pick 9 and say 12 and 83 and put them here, 9, 10, 83, the problem is that if I do this again randomly, I might pick these 3 again. See the problem? So as soon as we pick these 3 randomly, we have to take them out of this table. We have to somehow remove them. Otherwise, we're going to pick them again, probably, at some point. So there would be redundancy in the groups. Each person has to be assigned only to one group. We cannot assign them to other groups simultaneously. So what is the solution? What I can do is that I can create a shuffling, a randomized sequence of these IDs. Just randomize it. So let's say you have numbers from 1 to 10 here. What I do is that I collect them all, I mix them together, and then I sort them again in this interval. That's what I'm going to do. So I pick these numbers from 1 to 99, and then I randomize them. How do you randomize it in MATLAB? Randperm. So you want to create a randomized sequence of these numbers, and that's what randperm does. So we have a sequence that goes from 1 to 99, right? So let's see what randperm does. Say randperm 5. What does it give us? It gives us a randomized sequence of numbers from 1 to 5. Instead of being in order from 1, 2, 3, 4, 5, we get 1, 5, 4, 3, 2. It's just random, right? If I do it again, I get a different random set again. Why do I get the same thing? I think if I say, what was that?
It's different.
Oh, it's different? Yes, okay. But it's very similar, right? So 5, 4, 3. You see the human mind illusion? Yes.
Is there a random possibility that it fall in order? Not one of them?
Yes, that's just one possibility. And it could happen. If it happens, I would accept it. Because if I'm so lucky to get that number out of this. So what is the probability that you get that sequence? It's really rare. It's extremely rare. As soon as you have, what is that probability? So it's like 1 over 5 times 5 times 5 times 5 times 5. It's 625 times 5 inverted. Because, see, here is the problem. So we have 5 numbers. This is really interesting problem, guys. Listen to this, and then if needed, I will give you more time. But this is a very important, interesting problem that you will encounter in your future life as well. We have a few minutes. So we have 5 boxes, and one possible sequence for these 5 boxes is 1, 2, 3, 4, 5. But that's not what we want, right? Because this is just the boring sequence that we had initially, right? So we want something other than this. But what's the probability of getting this sequence exactly in these boxes? No, it's probability cannot be larger than 1.
1 over 5.
1 over 5 factorials, exactly. How do you get this?
Actually, it would be 5 times 4 times 3 times 2 times 1 because it's 5.
Excellent, yes.
Oh.
So let's say we want to fill the first box. How many options do we have for the first box? 5. So I have 5 options, but as soon as I put one of them here, how many options do I have for the second one? 4. So it becomes, 4 possibilities for the second one. How about the third one? 3, 2, and 1. So the set of all possibilities of sorting these numbers randomly in this sequence is 5 factorial, which is what? 5 factorial 120. So, but this sequence is just 1 out of that 120. So the probability of getting, the chance of getting this sequence randomly in this box is 1 over 120. What is it for 99 people then, to get the exact same sequence as we had in this 5? What is the probability that we put all these numbers in order in 99 boxes? 1 over 99 factorial, right? So let's try it. Factorial 99. It's 10 to the power of negative 156. If I wanted to give you an idea about how big this number is, if you invert it, it becomes 10 to the power 156. And that's longer than the age of the universe. And doesn't matter, and also including its future. So it doesn't matter how far you go in the future, this number is still bigger than the age of the universe. Okay? So your odds of getting the same sequence again for our groups is basically visually nothing. And if it happens, I will accept it, and then I will quit teaching and my life forever, because it's just impossible to get that sequence. All right, I'll see you on Monday because we want to discuss the second problem in homework and the third problem. Wednesday is closed, so Wednesday we don't have class.
You're going to be in